Hello everyone, welcome to the P1 program. This lecture is also called P108.6, the same, and this is the problem 2. Okay, this is P2, problem 2, where we do another problem for the application of the Newton's laws, right? So that's the purpose of this lecture here. So what I'm going to start off is that I'm going to set up that problem, very easy problem, very useful problem. Will get you your imaginations, right? It will trigger your imaginations and make sure that you get a basic understanding of how to handle a problem. So first of all, I'm going to assume that there is a cart, right? A cart or a box, something like that. Let's call it a cart. Okay, and this cart is on the surface of a table. Okay, so on the surface of a table. Okay, and there is a string attached to it, and on this side there is a pulley, right? So there is a pulley just like that. Okay, there is a pulley, and the pulley suspend a weight, right? Let's call this weight some block B. Okay, this is the block, right? So this is the system. There is a block and a cart. Okay, now I want to find out in a general case. I'm going to call this cart has some mass mc and block has some mass mb, and the frictional coefficient is some mu s or something like that, mu k, kinetic friction. Okay, so mu k, and other thing is there is a tension in the string. Okay, there's tension in the string, there will also be tension here. Okay, so these are the whole cases here. Now this is going to accelerate, the cart is going to accelerate with an acceleration ac, the block is going to accelerate with an acceleration ab, right? They will both be the same because they are connected to each other, right? Acceleration of ac and ab will be equal. Okay, okay, so this is the system, right? We have defined the problem. Now I need to find out what acceleration is. Okay, that's the first thing, maybe in a different color acceleration is. And the next thing I need to find out is the tension in the string, right? Tension. And maybe I want to find out how much is the minimum frictional coefficient mu k, right? Mu k minimum. Okay, what is the minimum? What is the minimum frictional coefficient required to hold this cart, right? This cart to hold the weight of the block. Okay, that's the three questions that we need to find out the answer. So for that, what I'm going to do is that first of all I'm going to define the sign convention, right? That's the most important part, right? We need to know which side is which. So I'm going to take what goes up as okay, what goes to the right as positive and what goes to the left as negative. Okay, that's the first thing. Now the thing that goes to the up is taken as negative, and goes to the down is taken as positive. Why? Because this cart is going to move, right? This cart is going to move in this direction. If it moves, then we have taken the right direction as positive, right? Right is positive, right? After reaching this point, this cart is going to fall down. This cart is supposed to fall down and goes downward, downside. So at this point it must maintain that direction. So the downside must also be positive, or else we will have a discontinuity in direction, right? So the discontinuity meaning the cart is going to suddenly switch direction at the point of the pulley, right? So it suddenly switch the direction at that point. So we don't want that to happen. That's why I've taken the downside as well as positive, and to the right as well as positive, and to the left and up are taken as negative. So sign convention is in place. Now I'm going to split up this problem, right? For easiness, I'm going to split up this problem into two parts, right? Two parts, right? The cart and the block. Okay, two parts, cart and the block. The first part is the cart. Okay, the cart part. Cart part. Now you can see the cart is like this, right? With some frictional coefficient with some mass mc and mu k. The cart is just like that. Now in the there is a pulley here and there is a tension C. Okay, now the cart is in place. Now in the x-axis, what are the forces here? So in the x-axis, you can see that the basic equation F is equal to some ma vectors both sides. Now what you can write down is that the in the x-axis you see there is frictional force in this direction, right? Friction is in this direction and the pulley is pulling with some tension, right? Tension in the right direction, so tension is in the right direction. So you can see that's the two forces in the x-axis, right? So the friction which is to the left, that is taken as negative, so Tc minus friction must be equal to some m of a of cart, right, in the x-axis. Okay, let's call that equation 1. Okay, and now in the y-axis, okay, I'm going to do different color. So in the y-axis you can see there is the gravitational force mg, and then there is the normal force, right? So normal force. So that's the two forces in the y-axis. Again, F is equal to ma. So you can write the forces are gravitational force, which is to the downwards, that is positive, right? So there is gravitational force mg minus normal force to the up, which is negative, must be equal to some m of the cart. This is also the cart AC in the y-axis, right? So you can see that this thing is based on the ground, right? It is not moving. That means the acceleration in the y-axis is 0, right? It cannot go break the table and go up and down. It cannot do that, right? So acceleration in the y-axis is equal to 0. So you can see mg minus n is equal to 0, or mg must be equal to n. Okay, so mg is equal to n. Let's call that equation 2. Now I can do what I can do is that I can substitute the value of n in equation 1, right? So in equation 1 I can substitute the value of n. Where is n in equation 1? So you can see Tc, right, minus frictional force is just friction will be normal force times the frictional coefficient mu k, right? So that will be the friction force. So Tc minus normal times mu k must be equal to some m c a c x, right? So now I can substitute that into this equation, no, n in this equation, and you get what? Tc minus mg mu k must be equal to mc a c x, right? So acx. Okay, so we have found out Tc as well. Let's call this let's simplify this a little bit further. So Tc can be called as mcacx plus mg mu k, right? So let's call this equation 3. We have found out the tension. Okay, equation 3. Now what I'm going to do is that I have found out, okay, what is the problem? Okay, I have found out the tension in the string, but there is a problem here, right? I don't know what acx is, right? I don't know what that value is. So tension cannot be determined without knowing acx, right? So acx has to be found out. That's the one missing factor here, right? So and also the tension in the string, right? If you look at this problem, you can see that this tension in the string will be equal, this tension will be equal to this tension, because they are both connected to the same string, right? So this tension will be equal to this tension. So Tc will be equal to T general T, so you can call Tc as T as well. Okay, so T, this is equal to T. Okay, that's the general tension. Now in order to find out the tension, common tension, I need to find, only thing I need to find out is acx, right? So I'm going to do that. So for that I'm going to take the second part of the problem, which is the block, right? There is a block here, and it is attached to the pulley. There is tension in here, and there is the gravitational force, which is m block times g, right? That's the only force here. This is the block. Now you can write down the equations of motion, basic equation, which is Newton's law, second law, and F is equal to ma. So now in the x-axis, right, in the x-axis you can see there is what in the this x-axis there is no motion, right? It's not going anywhere, right? So it's not going anywhere. In the y-axis you can see it's not going anywhere. So you can write down that in the a block of x is equal to 0. If you want, a block of x is equal to 0, there is no force in x-axis. But now in the y-axis you can see there is a tension going up, which is negative, right? What goes up is negative, and what goes down is positive. So mbg, which is a gravitational force, is acting downwards, which is positive. So you can say that in the y-axis you can say what minus t plus mbg must be equal to the acceleration m of block times a of what block y, right, in the y-axis, right? So this is equal to a by is equal to a, which is common acceleration, because they are both accelerated, they are both connected to the same thing. So you can call a c x must be equal to a c y is equal to a b y is equal to a, right? So because they are both going in the same direction, they are connected, right? If the cart is accelerated, then the block is accelerated with the same acceleration, because they are both connected. Okay, now so we got the case of block. Now let's simplify that as well, right? So simplifying that, you get t must be equal to some m b g minus m b a, right? So now a b y is a, so we got that as well. Now what you can do is that, now what I can do is that, let's from equation 3, right, from equation 3, tc is equal to mca, or you can simplify this equation as t is equal to mca plus mg mu k, right? So okay, so let's write down here m, this is of the cart, so m is equal to mc. Okay, so let's write down that equation. So in that equation it was like t is equal to some mca plus mu k times mcg, right? So that's the equation right there. Now what I can do is that I have two equations with two unknowns. First unknown is t, I don't know t. The second unknown is a, I don't know a. Now I can substitute one value based upon your choice. You can substitute one onto the other. I'm substituting t here in the second equation. So you get mbg minus mba must be equal to some mca plus mu k times mcg, right? So substituted that, and I'm going to take out a as a common, get to the other side and taking a as a common, and so a times mc plus mb, right, must be equal to this mb remains on this side, so you get mbg minus mu k times mcg, right? So that's what you get, right? So you can calculate a must be equal to some m mu b g minus mu k, sorry, mb mu k times mcg by mc plus mb, right? So we have found out the acceleration. Now what I can do is that I can substitute the equation acceleration into the equation of tension, right? So I can just substitute that into this equation of tension, and suddenly I'll get the equation for tension based upon the acceleration, right? So I'm going to substitute a into this equation. You get t must be equal to mc times A, which is what, so you can do that yourself, but anyways I'll do this. Okay, mbg minus mu k mcg, right, by mc plus mb must be plus mu k mcg. Okay, so that's the tension acting on that string for that mass. Now you can, you know, all these values, right? You, if you have a problem like this, you will get all these values. You can get mu k, which is the friction, you know, the mass of the block, mass of the uh, cart, you know, the gravitational acceleration. That's all you need, and you can find the tension. Basic. This doesn't get better than this. Okay, so this is the tension. Now one more question was there. It was that how much what, how much friction has there. Okay, there was the question. Okay, so I thought, okay, what is the minimum friction, minimum frictional coefficient, right? Mu k, what is the minimum value of mu k to hold these two weights, right? So these two weights has to hold, what is the minimum value? Well, we can do that in a simple way, I think. Yes, let's do this using the equation of acceleration. Okay, using this equation of acceleration, you can, if that thing, if these two things are connected like this, right, these two things, if it has to hold, okay, let's assume that they have the same mass. Okay, m and m, they have the same mass. Now how, what minimum value of friction must be there to make sure that this thing doesn't slip? Okay, so that means if it doesn't slip, then acceleration will be equal to 0, right? So if it doesn't slip, then the acceleration will be equal to 0. So you can put in this equation, you can substitute the value of acceleration is equal to 0, and you can find the frictional coefficient. So these are both the same masses, I'm assuming it to be the same masses. So now let's do that. So acceleration is equal to 0, so a equal to 0 must be equal to some what, mu b g minus mu k, sorry, mb. Okay, I'm confusing, mc g by mc plus mb, right? So this was the equation, I'm putting it to 0. Now I'm assuming that they have the same masses. What if the same masses, 5 kilograms, are holding? What is the minimum friction to make sure that it doesn't slip? Okay, that's the intention here. So I'm going to put mc must be equal to mb is equal to some m. Let's assume that's 5 kilogram. Okay, so some m. Okay, so you can say that, so this is both the equal, so you can say mb, which is m times g minus mu k times m times g by mc plus mb is equal to 2m, right? So this must be equal to 0, right? So you can say that what, you can take out mg in the numerator, so mg times 1 minus mu k must be equal to 2m, right? So now you can cancel m, so it doesn't matter what the weight is, if it is 20 tons or 20 kilograms, the same friction has to be there. That's a very important factor, right? So you must remember that even if it is 20 kilograms or 20 tons, the same friction has to be there to maintain. So it's independent of mass, the mass cancels. So you can see that mu k must be equal to, if you solve this, you can say 1 minus mu k must be equal to 2 by g. So mu k is equal to 1 minus 2 by g, right? G. So mu k is equal to 1 minus 2 by g. So if you solve this, you get 1 minus 2 by 9.8, right? So you get something like 0.79 or something like that. So you get 0.8. So this is the minimum frictional coefficient required to hold two weights in place, right? Two weights hanging on to one another, minimum friction required, doesn't matter how much the weight is. It can be 20 ton, 20 kilogram, 100 ton, doesn't matter. If the frictional coefficient is 0.79, minimum frictional coefficient, if it is 0.78, it will slip. If it is 0.8, then it will hold, right? So the minimum threshold of maintaining a weight, okay, the friction, minimum frictional coefficient is 0.79. So we have found out something very interesting and very useful. I hope you guys benefited from this. So this is how you solve a problem, this is how you approach a problem. So the first step is to go to the x-axis and y-axis. You can split the problem into two halves if you want, separate systems, two systems. Then go about x-axis and y-axis, you apply F is equal to ma. That's all you need to do. Okay, then you solve and you get your answers. So I hope you guys benefited, and let's see you next time. Okay, all the best.